Hello, in this video, I'm going to explain the second programming assignment. Uh, it's about writing a program that performs encryption and decryption using a simple transposition technique inspired by rail fence cipher algorithm. It seems to be very complicated, but it's pretty easy. I'm just going to show you with a simple example what I mean. And you will understand what you need to implement for the second assignment. This is a very simple example. Let's say you're going to encrypt a message before sending it out through a communication channel, let's say through an internet communication channel, to provide some level of security and avoid the eavesdropping attack by malicious actors. Let's say you're sitting on a base of a military base of a certain army, and you want to send a message to your friends in another base of the same army. You don't want your message to be intercepted at the middle of the way and be revealed to your enemy, right? So let's say your message says attack postponed until 2 a.m. And if this is the message that you sent with this plain text, it's not going to be secure. So how do you make it secure? We are basically are going to encode it into a ciphertext, or we are going to basically move the letters of this word around and mix them in a bag of letters so that what the output wouldn't be meaningful. The output would look like a mixed bag of letters that doesn't make any sense. And this way, if your message is eavesdropped by malicious actors at the middle of the way, the enemy cannot understand what this message says. So basically, we're going to mix these letters in a bag of letters and then make it unreadable. But we need to do it in a way that our friends on the other side of the communication channel, the receiver side, can retrieve the same message that says attack postponed until 2 a.m. So we want to encode this message into a ciphertext so that the enemy cannot understand this message. But when the receiver receives it, they can retrieve the same message and they understand what we are communicating. The first part where you change this to a bag of letters with random order that is not readable is called the encryption algorithm or encryption step, encryption part. And the part that the receiver receives the encrypted message and retrieves the original plain text is called the decryption algorithm. So every encryption mechanism has two algorithms: encryption on the sender side and decryption on the receiving side. I'm going to show you both encryption and decryption steps for this example, and then you will know exactly how this programming assignment can be done. Let's start by the encryption steps, right? Let's say you want to encrypt this plain text. How do you do this? The first step is to get rid of all the non-alphabetical letters, like punctuations or white spaces, like this dot or this space. You should get rid of all of it. Second step, make all of the letters lowercase. So if you have an A capital or an M capital letter, you make them lowercase. Third step, by the way, by the end of the second step, let's say you have L letters. So if I have this string and I get rid of all the punctuations and a space, I will be left with 25 characters. You can count it yourself. The third step is to place all the letters in a rectangular shape 2D array with certain dimensions n by m, where n is the number of rows and m is the number of columns. And when I say place them in a 2D array, I mean fill the array row by row from left to right and from top row to the bottom row, in a way that all the rows are full with the possible exception of the last row. And if you want to understand what I mean, this is the figure that illustrates all of that. Let's say the message was attack postponed until 2 a.m. So you basically place the first few characters for attack here, and then the postpone would be postponed. That's the word postpone, and then until comes after that, and then 2 would be TWO, and then AM would be this. The final part of it, which is XYZ, is basically placed here because we want to pad the last row to make it as long as other rows. As you see, every row has 7 characters, but the last row has only 4. So we have a shortage of letters to fill the last row. Basically, the idea of third step is when you have a non-full last row, you need to fill it with a sequence of adjacent alphabetical letters ending at letter 0. What does it mean? It means if you have 3 empty spaces, fill it up with X, Y, Z. If you have 1 space left, fill it up with Z. If you have 2 spaces left, fill it up with Y and Z. If you have 5 steps left, fill it up with V, W, X, Y, Z, right? And, just if you have like 6, U, V, W, X, Y, Z. Basically, that's how you fill the last row. And after doing that, you have a perfect 2D array with all full cells. Now you may say, okay, that was an easy step. What is the dimension? How do I know the dimensions of my 2D array? What is N and M? You need to calculate N and M yourself. Basically, M is going to be given to you as this length of an encryption key. What is encryption key? I'm going to explain it in the 4th step. But the length of that encryption key is the number of columns of this 2D array, which is M, right? And N, which is the number of rows, can be calculated using this formula. If you have L letters after step 2, which in this example was 25, and you know what M is, which is the length of your encryption key, which I will say later it's going to be 7. Divide 25 by 7, the answer would be 3 point something. But you need to round this number up to the closest integer. So 3.7 something rounded up would be 4. So the N would be calculated as 4. So there's a formula for N and M. You basically know exactly what N and M should be for the 3rd step. So that's going to conclude the 3rd step. You know what to do in the 3rd step. The 4th step would be after this 2D array is full. In this case, N is 4, you have 4 rows, and M is 7. In the 4th step, we're going to take advantage of an extra information that is given to us, which is called the encryption key. Encryption key is a piece of information that is given to both sender and receiver of the message, so they know exactly how to do the encryption and decryption. So they need to have some shared secret data, we call it the symmetric key, that no one else has access to, and this will make the 2 parties communicating to each other communicate with secure channel, with a secure channel, because no one else can understand what they say. They don't have access, no one else has access to key except the sender and receiver. The key for this encryption algorithm is basically a permutation of numbers from 1 to M, where M is the number of columns. So in other words, the key will be a permutation of numbers from 1 to 7 in this example. You see, this is a key. 4312567, right? It's a permutation of numbers from 1 to 7, right? And this permutation helps us to construct the ciphertext. So we're going to convert the plain text into what we call it as a ciphertext, which is an unreadable version of the plain text, right? So that no one can eavesdrop the messages. So let's see how the fourth step can be performed. You need to concatenate the letters column by column from top to bottom row in an order specified by the key. Let me tell you what I mean. First, you need to write down the key elements, which is 4, 3, 1, 2, 5, 6, 7 on top of each column. As you see, this is going to be 4, this is going to be 3, this is going to be 1, this is going to be 2, this is going to be 5, this is going to be 6, and this is going to be 7. And as you see, each column has 4 letters. The first column is A, O, D, W. The second column is T, S, U, O. And the third column is T, N, T, T, N, A. And then so on and so forth. What you need to do is to concatenate the letters of each column in the order specified by the key. So based on what key says, this column, which made of TTNA letters, should be the first, right? So we basically first place TTNA. That's the first thing that you need to place, right? Let me show you. So this is the TTNA. That's going to be the first column. So this is the first column. Then the second column should be APTM. So we place APTM here. The next column is number 3, TSUO, TSUO. Then the fourth column is AODW. The fifth column is COIX. The next column is KNLY. And PETZ is the final one. This is going to give you the ciphertext. Ciphertext is the encrypted version of plain text using this key, which is going to be transferred through the communication channel. And anyone who looks at this, they don't understand what the message says. They don't understand attack postponed until 2 a.m. unless they have the key. Who has the key? My friend on the other side of the channel who is not an enemy, so he has they have the channel, they have the key, so they can decipher this and decrypt this. So that's the encryption algorithm. Now, what is the decryption algorithm? The decryption the algorithm is made of 5 steps. I'm gonna mention them one by one. Remember, the receiver has the same key. So the first thing the receiver has to do when it receives the ciphertext, which was this one, is to count the letters and find out how many letters we have. In this case, we have 28 letters. If you remember, the original plain text had 25 letters, but we added an XYZ at the end. We padded the plain text with XYZ to make it divisible by 7, which is the number of which is the length of the key. So first, we need to count how many characters we have in the ciphertext. Second step is to divide the length of your ciphertext by the length of the given key to obtain the number of rows that you need to have for your 2D array. So we have 28 divided by 7, which is the length of the key, and the answer would be 4. 4 is the row number, which was basically the variable n that I mentioned before. So we have m equal to 7, n equal to 4. After the second step, we know the dimensions of the 2D array. Third step is to break down your ciphertext into smaller pieces with equal length of length n, which is the number of rows. So basically, if you have the whole ciphertext, break it into 4 letter pieces, because here n is 4. So you need to break it into smaller pieces, each one with the same length, and do this all the way to the end. The fourth step is now that you have your ciphertext broken into 7 4-letter words, you have to place each word in a different column. How do you know which word goes to which column? Remember that for the decryption, we have the same key that we had in the encryption. So we know that the fourth word has to go to the first column. The fourth word is, this is 1, 2, 3, 4. The fourth word is AODW. This should go to the first column. If you look at the 2D array, AODW basically is the first column. And then the second, the third word should be placed into the second column. Third word is 1, 2, 3, TSUO. Then first word, which is TTNA, should be placed on the next column. The second word, APTM, next column. Fifth word, COIX to the next column. KNLY to the next column. And then seventh word should be placed in the last column, PETC. After the receiver does that, the receiver can basically reconstruct the 2D array that the sender had, right? So the receiver will get this whole 2D array. So they both now the receiver has access to the same 2D array that the receiver has access to the same 2D array that the sender had access to, or the sender had constructed. The last step is to just read the 2D array in row major. First, read the first row, then the second row, then the third row, then the fourth row, so on and so forth. That's gonna give you the plain text. So basically, the last step, we need to reconstruct the plain text by retrieving the letters in row major. First, the first row concatenated with the second row, and the rows should be retrieved from left to right. So the order is top to bottom, left to right. Now that you know what has to be done, what the algorithms for encryption and decryptions are, let's see the details of your program. This is the first programming assignment that you need to use command and arguments in it. And that basically means your main function should have a signature like this. The return value is an integer, and it gets 2 parameters, argc, argv. Argc basically is a number greater than or equal to 1, showing how many arguments you have. And argv would be an array of all the arguments, right? It's an array of char star. So assume that you have written your program, and the program executable is called Rail Cipher, and you want to run the program. In the command line, in the terminal, you basically say /Rail Cipher 7431257, and between each of these words, each of these numbers, you put a space. And after the last command argument, which is 7, you press a new line. That's gonna make your program run, right? When your program gets executed with this command, the first argument, which is argv0, would be the name of the executable. So we don't really care about that. That's not gonna give us any information. We're gonna begin at argv1. Argv1 would be the length of the key that we're gonna use for both encryption and decryption. That's basically the variable m, which in the example I showed you was 7. argv2 would be the first number of the key. If you remember, the key was 4312567, so the first number should be 4. So argv2 is 4. argv3 is 3 because the second number in the key was 3, and all the way to the argv8, which is going to hold the last number in the key, which was 7. If you remember, 7 was the last one. And argv9 would be a null pointer because that's how Unix command and arguments work. The last one would be an empty string, which is null. So considering the previous example, argc should be equal to 9, and argv has all of these values that I mentioned. One thing you need to remember is after you receive all these arguments in the program, you need to check the validity of them. And if they're not valid, you need to throw an error. You need to basically terminate your program immediately and print a message saying that it's a fatal error. You didn't pass the arguments correctly. How? For example, let's say if any of the arguments argv1 to argv1, argv2, and so on and so forth are not valid positive integers, then the program must terminate immediately and says you didn't pass an integer. Or if the key specified in the argv is not a valid permutation of numbers from 1 to m, for example, you have some duplicate numbers for the key, or maybe the range of numbers are not from 1 to m, where m is the length, which is the first argument. Then you need to terminate the program and say the key is invalid. Or maybe if argv1, which is the length of the key, is a number greater than 26, you need to also raise an error, because I'm going to limit the length of key to 26 numbers, no more than that. One more thing. After you check all the command and arguments and make sure everything is right, you need to start implementing your program. And basically, your program should support 3 commands. One is encrypt, one is decrypt, and one is quit. Quit is going to end the program. That's easy, right? Quit followed by a new line is going to end the program. Encrypt followed by a plain text followed by a new line should start encrypting the plain text, and it's going to print the encrypted text on the screen. Decrypt followed by a ciphertext should decrypt the ciphertext and regenerate the plain text. But you got to remember, for the given example, if I want to decrypt this ciphertext that is made of all capital letters, the answer doesn't need to be the same exact sentence that you see earlier, because this one has spaces in between. Some of them are uppercase, some of them are lowercase. All you need to do is to just print the following. You need to say, you need to print ATTACK-POSTPONEDUNTILTWOAMXYZ. You don't need to put the spaces between the word attack and postpone, or between postpone and until. You don't need to make the attack a character capital. You don't need to get rid of the XYZ at the end. You don't need to do any process to the value that you get after the decryption operation. And that's pretty much it. When you're submitting your program, make sure that you keep all the C files and H files in the submission zip file and the make file. Do not include the autograder. That's gonna hurt your grade. So only put a C file, which is the program that you have. If you have multiple C files, include all of them. If you have an H file, include that one as well. And if you have, and you must have a make file. The make file is mandatory. And if you don't have a make file, you're gonna lose about 10-15 points of your credit. So be careful about that. And finally, I want to show you 2 more things. First, I'm going to show you the expected output for the autograder. I have made an autograder for this, and I have 4 test cases. This is the expected output. The first test case has an invalid command and argument. It looks like this. The first command and argument is 4.5. The second one is -1. The third one is 2. And this is not a valid sequence of command and arguments. Why? Because this is not an integer. So your program should basically terminate immediately and say rail cipher, which is the name of the executable, colon, space, fatal error, exclamation mark, space. First CLA must be a valid integer, right? So it gives the reason why it has failed to continue execution of the program. The standard input doesn't really matter for the first test case, because the command arguments are not valid. Same for the second test case. The command arguments are not valid because after the first one, which is showing you the length of the key, we don't have a valid key, because this is not a valid permutation of numbers from 1 to 5, because you see a 0 here and you don't see any 4 here. If this was 4, then it would be a valid one. But because it's not, you're going to get a fatal error message on the output, and it should say the encryption key past the CLA is not valid. And then the next test case also has a similar problem. The command arguments are not valid because the first number, which represents the length of the key, is 28, and it's greater than the valid maximum number of numbers in the key, which is 26. 28 is greater than 26, so this is gonna cause an error, and you will print something like this. The encryption key length cannot exceed 26. The last test case has a valid key. The key length is 7, and this is basically the same sequence that we saw in the PDF file. And there are 3 commands that we need to take care of. The first command says encrypt this, same message, and the output is basically the same. This is what you need to print on the output. This is the ciphertext corresponding to this plaintext. And then if you decrypt the same ciphertext, it should print the plain message, but without any spaces and with an XYZ at the end. And then finally, quit is not going to print anything. That's pretty much it for the four test cases that you have in your autograder. Finally, I'm going to show you a very simple example of how to deal with command line arguments. I have written a very simple program. This is a good template for any program that you want to write in C with handling command line arguments. Basically, this program is a test program. It gets an argc and an argv as the parameters of the main and returns an integer. The return value of an integer, the return value of the main basically specifies whether or not we have an error while executing the program. If there is no error, we're going to return 0. That shows the success of the program. If not, we return a non-zero value. It's either a positive value or a negative value. The value that we return from the main, if it's a non-zero value, is called the error code that you can document in your program and say, this error code means this, this error code means this. So you give a clue to the operating system about why your program failed to get executed. What was the fatal error's reason, right? So these are very important etiquettes that you can always follow when you're writing a C program in Unix. The program basically starts this way. It says if the number of arguments is less than 2, that means if you have no command argument, then just print not enough CLAs and I'm sorry, just print this. CLA test, the name of the executable, colon fatal error, program needs at least 1 CLA. And return this error code. Now you may say, where did you do that? You just called error. Is this a function? This is not a function. This is a macro that I defined, and I will strongly suggest that you also use this macro. In order to use it, you just need to define it this way. It's a single line definition for this macro. What is a macro? Macro is a lightweight function that is not going to be handled by the compiler. And basically what it does is it replaces this line with the following. Do fprintf. Fprintf is a version of printf that prints on a certain output stream. I want to print on stderr, which is called a standard error stream, which is a little bit different from a standard output stream. If I was saying printf, it would print on stdout. stderr is an output stream that cannot be redirected by the user, so it always prints it on the console and the user always see it. You can redirect the standard output so that the user cannot see it on the output stream, on the console, on the terminal, but standard error will be inevitably printed on the terminal, on the console. So this is used always for printing error messages. So I will say fprintf, and I will pass the output stream, in this case, standard error, and I will basically pass the message that is the second parameter of this macro. Right? So the message would be this. and then semicolon to end the printf, and then return the code. Returning the code, which is the first parameter. In this case, I have used the constant value 1 that shows the error code. I'm returning from main, that's going to end my program immediately. And this is an error code saying that I don't have enough CLAs. Right? So I have defined this as a constant so that it makes my program more readable. Now, anyone, even if they don't understand C, then they look at this, they realize that I'm raising a fatal error and I'm returning with this error code. Right? So it's good to write programs that are readable, right? Easy to read. And the other if statement says if the argv1 is not an integer, then I'm going to print this error message and raise this error code and return with this error code. The error is again the macro, so I call the macro twice. This line check integer checks whether you have a real integer or not. I'm going to show you the function. The function is here. But if there's no error, then I'm going to run the program and do the main functionality of the program. The main functionality of this program is to just print out the first CLA as an integer followed by the value of the integer. The argv1 is a string, so it's not an integer. If you want to make it an integer, you need to convert the string to an integer. The way to convert a string to an integer in C is to call this function a2i. A2i will basically convert ASCII to integer, and that's how I have done it. And I will just print out the value. The last thing I want to mention is check integer. How do you implement the check integer? You need to get a string and check whether it's an integer. If the length of the string is 0, that means the string is empty, return false. If the string starts with a minus or a plus, that's an explicit sign. We'll skip that by doing str++. A string str is a char star, so when you plus the pointer, it's going to advance to the next character. If not, then we don't advance it. If there's no explicit parameter, explicit sign, we just gonna go forward. Then I have a while over the string value. This basically means give me the current letter that str points to. And if this is not the last backslash 0 that you will always see at the end of every string in C, that means we haven't reached to the end of the string. So we're going to keep going. In C, when you put 0 as the condition of the while loop, that means false. Non-zero is true. So if we haven't reached to the end of the string, this is not 0, so it's true. So it let the while loop continue. And in this if statement, I will say, give me the next character. If the next character is not a digit, is digit is a function that is defined in C type.h. If it's not a digit, then return false. But if it is a digit, keep going the while loop, right? Keep doing the while loop. And in order to set the str to the next character, I will do str++. So I will advance the pointer in the same line that I'm comparing the current character with a digit. If you don't return false in this while loop, that means all the characters are integer digits, so you're going to return true. Okay, so that's how the check integer works. And I'm just going to, that's how it works. Now, one thing that you may say is, why did you return true and false? We don't have Boolean in C. You're right. We return an integer, but I want to make my program more readable, so I will define false as 0 and true as 1. So this way, everyone who looks at my code, they can understand what's going on. Let me also show you how to run this. I'm just going to open the terminal, and I will say, let's run this CLA test. Without any command lines, you see the fatal error. If I say run it with this number, which is not an integer, it's going to give me an error. But if I say run it with 1, 2, 3, 4, it basically says there's no fatal error, so this program prints out the first CLA. And that's pretty much it. Thank you for listening. and hope you can finish the second assignment on time.